In this first chapter, we're going to cover the very basics of setting up a material in Cycles. Even if you're already familiar with this, I still recommend you watch this video because I'll explain some of the core principles of physically based shading. Now, before we jump in the deep end and work on the Ninja model, I'd like to show you some things in a simple environment, which over here is just a scene with a sphere and one lamp. If we switch into rendered mode, we can see what this will look like when it's rendered, which is much easier than having to press F12 every time we change something. So let's start by adding a material to our sphere. You'll notice we have some options to adjust, but it's not nearly as many as you're probably used to with the Blender internal renderer, and that's because Cycles relies heavily on the node editor. It's intended for us to create our own materials from scratch, adding only the elements that we really need and combining them in whatever order that we desire. This might sound intimidating at first, but you'll see that this allows us to be extremely flexible and create almost any kind of material we can imagine from only a few different simple kinds of building blocks. So let's split our window into a node editor on this side, and you'll notice that these are the materials or the nodes for the material on our sphere, and anything we adjust over here is going to be adjusted in the rendered view and also in the tree view over here as well, and of course vice versa. Now the tree view is okay for adjusting some small simple things like colors and roughness and things like that, but if you want to add new nodes and change around some connections, remove connections, make connections and stuff like that, the tree view gets a little bit difficult to use. So you'll find I'm always using the node editor instead and mostly just ignore this over here. Now the node we've got over here is a diffuse shader, which is basically just the diffuse component of our material. It's one of many different kinds of components we can mix together to create a material. And then on the right over here we've got the material output, which is just like the output in the compositor. It's the final node in the setup, and everything on the left sort of leads up from left to right to go to the material output. Now we have some shaders over here we can add, like a glossy shader, which is basically the specular component of a material. You'll notice that when I try and connect the glossy to the material output, it's going to disconnect our diffuse shader. And that's just one of the ways the node editor works. You can only ever have one connection going into an input. You can have multiple connections going out of a node, or out of a socket, but only ever one connection going into an input socket. So in order to combine the diffuse and the glossy shaders together before they get to the material output, we need to add another node, and that is the mix shader. Basically, the mix shader is a lot like the mix node in the compositor. It takes two inputs, and we get to control the influence or the ratio between them. On 0, we're not getting any of the bottom input, and as we increase this, we get more and more of that glossy shader, and when it gets to 1, we can only see the glossy shader and none of the diffuse. This is actually a really important feature in Cycles, one that keeps us from breaking the laws of physics. Specifically the law of energy conservation, which basically means that the amount of light that leaves a surface cannot be more than the amount of light that hits the surface in the first place. Which makes sense if you think about it. If you think of it like a tennis game, someone hits a ball to you, and when you hit it back, only one ball leaves your racket. There aren't suddenly two balls appear as you hit it. That would be kind of strange. Now, most older renderers like Blender Internal didn't really care about this. They simply added the specular over on top of the diffuse, which meant that the material would appear a little bit brighter than would actually be physically possible in reality. Also, when adjusting the roughness of the glossy, or the size of the specular highlight, you'll notice that when the roughness is low, or the highlight is small, it's very, very bright. But as you increase the roughness, it gets darker and darker and spreads out a little bit more. This is also due to energy conservation because the light is all concentrated in a small area, but once you increase that area, the same amount of light is spread out a little bit more, so it appears darker. This was of course also ignored by Blender Internal, except by one of the specular models, the Ward ISO model, but the rest of them didn't really care about it. Another reason why Cycles is more physically accurate is that it combines specular and reflectivity together in one node, the glossy shader. I've just added an environment texture so that there's something to reflect and we can actually see what the reflectivity is doing. And you'll notice that at a low roughness, the reflections are quite sharp, but at a high roughness, the reflections get a little bit blurry. Now, the reason reflection and the specular highlight are combined in the same node is because technically they're actually the same thing. The specular highlight is actually just the reflection of the light source itself. The reason they were separated in older renderers was just to reduce render times, because the appearance of a specular highlight was usually enough to fool the audience into believing that the material is shiny. But nowadays your average person has a much higher expectation of realism, so we've got to pay attention to how physics actually works. Cycles also renders these blurred reflections much quicker than Blender Internal, and our computers are much more powerful than they used to be, so we can't really use that excuse anymore. But finally, as a rule of thumb, always use mix shaders to combine two shaders together. There is also an add shader over here, but the problem is that when we're adding shaders together, we're no longer conserving the energy, which means there's more light leaving the material than there is coming in. There are some cases where you actually do want to use an add shader, such as for translucency and volumetrics, and that's because some shaders are just building blocks of materials and they're not really supposed to be used on their own, such as the translucent shader over here, which is kind of just the light that's leaving the back of the surface, and also the refraction shader, which is meant to be used with the glossy to build your own custom version of the glass shader, but there's not that much use for this. It's kind of a niche thing. And also then the volume absorption and volume scatter are meant to be added together if you want colored volumetrics. But don't really worry about any of this stuff for now. The rule of thumb is just to always use a mix shader unless you definitely know you have to use the add shader. And that's it for this video. In the next video we're going to cover some texturing with nodes, which includes the coordinate systems, mixing different textures together, and using masks and stencils to control the mixing factor.